Assalamualaikum and welcome back to my YouTube channel. This is me Sabah Farooq and today we are going to study Ampere circuital law. So student, before the statement I will tell you that Ampere circuital law is given by Andrew Mary Peter Ampere in 1826, and in his law he relates the two quantities that is magnetic field and current. And students, first of all we should know about the magnetic field and current. So as this Ampere's law is included in unit 13, electromagnetism. So electromagnetism is study of electricity and magnetism, how change in electric field creates magnetic field and how change in magnetic field creates an electric field. So students, first of all we should know about the statement of Ampere's circuital law, and the statement is for any closed loop, it means that for Ampere's law we will take the closed loop, and in that closed loop the sum of length element multiplied by component of magnetic field. I will just write multiply by component of magnetic field, and parallel to each element is proportional to the current enclosed by the path. So student, this is the short form of statement I have wrote here, but I am repeating it. For any closed loop, the sum of length element multiplied by magnetic field, it will be directly proportional to the current enclosed by that path, or mathematically we can write it as summation of B dot delta L, summation of length element multiplied by magnetic field, and it will be proportional to the current. And whenever we will remove the sign of proportionality, it will be mu naught I. So this is the, according to statement, this will be the mathematical form of Ampere law. And now we are going to prove this, how this change in magnetic field with a sum of length element, it is equals to change in current in a loop. As Ampere law is the relation between magnetic field and current near the current carrying conductor. When there will be no current, then the compass needle that Oersted took in his experiment, it will show no deflection, zero deflection. Okay. Now to prove this statement, B dot delta L, summation of B dot delta L, it will be equals to mu naught I. First we will assume consider our test point P located at the distance R. So we are taking the point P that is located at the distance R. Let's suppose this is the closed loop or Amperian path, and this will be the wire or any conductor, and this is the radius, and this will be the point P. Now R will be the distance from current carrying conductor, and where we want to find the magnitude of magnetic induction B. As we know that the magnetic field, it will be inversely proportional to the R, so I can write this B magnetic field, it is inversely proportional to R. It means कि students एम्पेरियन पाथ का कंडक्टर से जितना ज़्यादा डिस्टेंस होता जाएगा उतनी ही वहाँ पे मैग्नेटिक फील्ड जो है वो वीक होगी. सो दिस रिलेशन वी कैन सॉर्ट आउट इन द फॉर्म ऑफ B is inversely proportional to R. Now the another relation is, we can write this as B is directly proportional to length. It means कि लेंथ, अगर हमारे पास लेंथ ऑफ कंडक्टर ज़्यादा होगी तो वहाँ पे मैग्नेटिक फील्ड भी ज़्यादा होगी. कॉल इट इक्वेशन 2. नाउ कंपेयर और रिलेट इक्वेशन 1 and 2. वी विल गेट B is proportional to L over R, and we will remove this proportional sign with constant P equals to, and here what we will use constant is mu naught divided by 2 pi into L divided by R. So what is mu divided by 2 pi? This is the constant of proportionality, and mu naught is the permeability, means allowness of material, or mu naught is permeability of vacuum, and its value of mu naught is 4 pi multiplied 10 power minus 7 Tesla meter per amperes. So or we can write it as 4 pi multiply 10 power minus 7 Weber per ampere meter. Now we will take this length element as it is a Amperian path, and the length element will be equals to summation of delta L. It will be equals to 2 pi r. Now it means that it is equals to 2 pi r. So this is r, and we will put this value, call it equation 3. Whenever we will put this value, or we can use this value here in this equation, call it equation a. If we will put this value in equation, so we will get summation of b dot delta L. It will be equals to b delta L, and it will be equals to mu naught I divided by 2 pi r multiply delta L. And here we have seen delta L is equals to 2 pi r. It will be b dot delta L. It will be equals to mu naught I divided by 2 pi r into delta L is equals to 2 pi r. So this will be cancelled, and we are left with b dot delta L. It will be equals to mu naught I. So here we have proved this, that any closed loop, the sum of length element multiplied by magnetic field, it will be equals to current enclosed in that loop. And as we have derived, this will be the derived mathematical form of Ampere's law. The closed path is called the Amperian path. This is a closed path, and we can say it as Amperian path. And in general, this law can be used, or this law can be applied to any closed path around a current. Students, as we have derived this relation and we have studied the statement of this Ampere law, behind this there are few limitations of Ampere's law. And the limitations are that this law is not valid when charges are at rest, and this is not valid when AC current is used. And the third limitation is this is not valid when non-uniform magnetic field is used. And this was all about the Ampere's law. Students, अब थोड़ा सा मैं आपको परमेबिलिटी के बारे में बता देती हूँ. यहाँ पे तो हमने चूँकि परमेबिलिटी ऑफ फ्री स्पेस यूज़ की, लेकिन वैसे परमेबिलिटी होती क्या है. परमेबिलिटी ऑफ वैक्यूम जो है वो हमने लिया कि 4 पाई मल्टीप्लाई 10 पावर माइनस 7 वेबर पर एम्पेयर मीटर होती है, और यहाँ पे एम्पेयर टर्न मीटर भी हम इसको कह सकते हैं. ये एज अ रेफरेंस यूज़ होती है. और रिलेटिव परमिटिविटी का, जैसे हमने परमिटिविटी और परमेबिलिटी ये दोनों जो हैं वो डिफरेंट टर्म्स होती हैं. इसका डिफरेंस भी अगर आप लोगों को नहीं पता या आप लोग जानना चाहते हैं तो मुझे बता दें. इसके लिए मैं एक शॉर्ट वीडियो बना दूंगी जिसमें मैं आपको इसका डिफरेंस क्लियर कर दूंगी. तो रिलेटिव परमेबिलिटी को फाइंड करने के लिए फार्मूला क्या है. रिलेटिव परमेबिलिटी इज इक्वल टू permeability of dielectric divided by permeability of free space. Because it is the ratio of two permeabilities, so it has no unit. And if it has no unit, then definitely it is a dimensionless quantity. Magnetic materials such as iron having the relative permittivity of few hundred. So students, for different material, like I have used the conductor wire. So if we use iron or any steel or any other material, then the permeability according to that material will be changed. And students, for diamagnetic, permeability of free space will be less than 1. Keep it in mind. This is the important information, that for I should write here that for diamagnetic material, permeability of free space will be less than 1. And for paramagnetic material, this permeability of free space will be greater than 1. That is, what are those paramagnetic materials? Aluminum or platinum. And what are diamagnetic material? Like copper or bismuth. And for ferromagnetic material, for ferromagnetic material, this permeability of free space will much greater than 1, means that it will be equals to 3, 4, 5 up to so on. And for vacuum it is taken as, for vacuum it is taken as it will be equals to 1. And vacuum means air or space. And for any material we can find it as relative permittivity. This will be relative permittivity, and this is equals to permittivity of dielectric divided by permittivity of free space. So this was all about the Ampere's law. And थोड़ा सा हम दोबारा से समराइज़ कर देते हैं. स्टेटमेंट इसकी क्या थी कि फॉर एनी क्लोज लूप द सम ऑफ लेंथ एलिमेंट मल्टीप्लाई बाय magnetic field parallel to that will be directly proportional to the current enclosed in that loop, and we can write it as summation of B dot delta L. It is proportional to current enclosed in it. जब हम proportionality का साइन रिमूव करेंगे तो so we will use the constant and that is permeability of free space. तो यहाँ पे हमने कंसिडर किया हमारे पास एक एम्पेरियन पाथ है क्लोज, और हमने कंडक्टर को रखा, इसकी लेंथ जो है R होगी, कोई पॉइंट P लिया, तो वहाँ पे हमने देखा कि जो मैग्नेटिक फील्ड है वो डायरेक्टली प्रोपोर्शन है, इन्वर्सली प्रोपोर्शन है रेडियस के, और ये डायरेक्टली प्रोपोर्शन है लेंथ के. इसी तरह से अगर यहाँ पे हम लेंथ एलिमेंट ले आते हैं तो इट विल बी इक्वल्स टू बी डॉट एल इज़ प्रोपोर्शनल टू एल ओवर आर, या हम इसको ऐसे लिख सकते हैं म्यू नॉट इंटू 2 पाई प्रोपोर्शनलिटी का साइन रिमूव करके इंटू एल ओवर आर. तो यहाँ पे परमेबिलिटी की वैल्यू हमारे पास क्या है, 4 पाई मल्टीप्लाई 10⁻⁷ टेस्ला मीटर पर एम्पेयर, और लेंथ हमारे पास जो है वो क्लोज लूप की 2 पाई आर की इक्वल है. जब हम इसको इक्वेशन में पुट करेंगे 2 पाई आर विल बी कैंसिल विद 2 पाई आर, वी आर लेफ्ट विद बी डॉट डेल्टा एल इज इक्वल टू म्यू नॉट आई. तो दिस विल बी द proof of mathematical form of Ampere's law. So for such videos subscribe this channel and take care. Allah Hafiz.